presented by the also ever insightful Dr. Hossein Tafti, and we will also get to hear from our wonderful student ambassador, Hanane Oudli. So could you please just take note of the following: the copy of the slides, as well as a PDF and the link will be sent to you between Monday the 14th and Tuesday the 15th. So should you not get it in your junk in your inbox, please check your junk and spam mail. That's where it could alternatively be. So for this, you will receive a certificate of attendance, which will be provided to you for free. You will just have to scan or take note of the link that will be presented on the screen towards the end of the presentation. And this will ultimately get you to fill in a survey, and you'll also be receiving the certificate between Monday the 14th and Tuesday the 15th. That will also enter you into our competition. So I'll be handing it over to Dr. Hossein Tafti, and he will be doing our presentation today. Dr. Tafti, if you are ready, you may take control of the screen.
Thank you very much. Thanks everyone for joining this session. Just to make sure you guys are hearing me well, is that right?
Yes, sir.
Yeah, good. Thank you very much. Thanks everyone for joining this session of Virtual Open Week, and I will be talking in the next hopefully 20 minutes around the electrical engineering and its aspects, and what do we as EIT offer in electrical engineering, and we try to understand these aspects. I myself, I have been working in electrical engineering in Australia and overseas for more than 10 years. In my main expertise is on renewables integration, power electronics, and power systems. I have received a PhD from Nanyang Technology University in Singapore, and yeah, I have been with EIT in the last 3 years almost. And at the moment, I'm the course coordinator for the Bachelor and Master of Electrical Engineering. The agenda for today, we go first through the basics of what are the electrical engineering and what is renewable energy, etc. Then we go quickly through what EIT offers and different pathways that we have in electrical engineering. So everything around us, including the screen that we are looking at, including the laptop that we are using, and including any of the household items that we have, are electrical engineering. And that's why electrical engineering is nowadays becoming every single point of our life and our career. There are different aspects that we can think in electrical engineering. One of the first one would be like electromotive trains or electromotive cars that are based on power system, and they also use energy storage systems, and they are fully nowadays fully electrical based. The other side that we can think in electrical engineering are electromagnetic and electromagnetism that we have in electric motors, and the concept that we have in these electrical motors and motor derived systems to convert the electrical energy into mechanical energy or vice versa. Of course, in addition to that, we have electronics such as our mobile computers, processors that we have, microprocessor units that we have, etc. And these units, they use electronics, and they use, of course, semiconductors for transferring data, for processing the data, etc. So that's another aspect that we have in electrical engineering. Another aspect that we can think of is about communications that we have between different processing devices, like our mobiles, between like wireless communications that we have. They also are part of the electrical engineering, and the devices and components that we are designing and we are using to generate this part of this type of communications are another part of electrical engineering. So electrical engineering has many subfields. As I mentioned, it has computer systems, and programming that we have for computer system to use the embedded systems and to use different electronic components that we have for processing data, etc. Another important thing that we have in electrical engineering are the devices that we use for control, such as simply controlling the position of a lift, controlling the position or direction of an airplane, etc. All these come under the big umbrella of electrical engineering, and of course they are providing those different subfields that we have in electrical engineering. Electrical engineering connects every electrical energy that is produced and used also in homes. That's another part or subfield that we have. The energy that we are producing from conventional power plants that is being produced and is being transferred to our household, and all these interactions, all of these components are really considered as different subfields that we have electrical engineering. Machines that transmit energy, the components that we have for measuring temperature, for measuring height, etc. All of these components are different subfields of electrical engineering. Electrical engineers, as an electrical engineer, we are contributing to build power plants that generate electricity, new technologies for harnessing electricity like renewable systems. We also contribute towards designing the power transmission line and distribution system to bring the electricity from generation towards our houses. As an electrical engineer, we also work and contribute towards telecommunication platforms for, let's say, communication between mobile stations, wireless, 5G, 4G, 6G, and different types of communication that we have. We also contribute towards lighting of houses and offices, etc. By nowadays, especially, we are using the LEDs, which are newer technologies of lighting, and they also use power converters to generate DC voltage around them. And of course, as an electrical engineer, we also design and contribute through electronic components of computers that are being used for processing everything that we see around us. If we look at the technology and its growth for electrical, from some time ago, from let's say 1,400 till nowadays, we can see the growth and innovations that we have in technology nowadays. It's drastically and exponentially increasing, especially nowadays in the last few years with the high advantage and high advancements that we have in artificial intelligence, etc. The growth that we have in the technology has been advanced exponentially, and as a result, every day we can see computers, processors, mobiles which have higher and faster computing facility. And just as a simple example for just processors, every 2 years the I mean, this is the scientific data that every 2 years the number of processing units that a processor can do are getting double, and the number of ICs and integrated circuits that we can combine together to make a processor are getting double. And this means the technologies are going towards more compact, more faster solutions, etc. So, and this graph shows you to some extent that advancement that we have in the technology and the exponential growth in the technology and advancement of the technology in the last few years, especially. On the other side, we have the demand for them. And as our on the demand, we are human for as a demand. We are every day looking for faster processors, smaller home appliances, lighter home appliances, smaller mobiles, etc. And all these demands are encouraging the technology to go towards a more compact, faster, more reliable, as well as more efficient solutions that we have. As another example, we can look at what we have as smart grids, and just to give you a quick overview, smart grids are uh, having extra information and extra sensors of different nodes and different buses of the system, and as a result of that extra information, we can provide extra optimization and reducing the losses, increasing the efficiencies and reliability in our systems. So that's another biggest growth that we have nowadays. And now, if you just look at this simple technology of smart grids, or the concept of a smart grid itself, the advancement that we have or we need for processing the data, for collecting data, is growing vastly and drastically. On the other side, we see that nowadays in all different countries that we are living around us, electric cars are becoming very popular. And that's another advancement that we have in electrical engineering. And as a result, we need more compact and reliable and efficient battery technologies, which is another subfield in electrical engineering. And we also need autonomous vehicles that they can go driverless, and as a result they need to have sensor, they need to have programming, and they need to have that more reliable performance. And as a result of that, also we need to have higher number of charging stations, car interiors, and um, electric utility improvements, because now having many charging stations around us, they are going to have negatively impact the power grid or electricity grid, and as a result of that, the we need to have extra new what we call as improvements in the electric utility as well. Another advancement that we have in electrical engineering is the integration of renewable resources, and they are becoming popular, or they have already become popular now in many countries due to the global warming issues that we have because of the fossil fuel reductions that we have and the prices that we have. And these renewable resources, including solar, including tidal power, wave energy, and etc. Not only they have in addition to the benefits that they have for our environment, they also bring many challenges. Even though as a public we think renewable energy is a good source of energy, as an electrical engineer we are facing many challenges by integrating these renewable resources, and this has many reasons, and one of the main reasons is that the output power of renewable resources are not constant. They are dependent on the environment. For example, in solar system, they are dependent on the solar irradiance, or in wind system, dependent on the wind speed, right? And as a result of that fluctuation of the environment, change in the environment, the the output power of the systems varies and sometimes becomes unpredictable, and as a result, the power system is facing new challenges. And this is our real challenges that we need to fix as an electrical engineer. Of course, there are many solutions. One of the solutions is integration of energy storage systems that are higher efficient, and they can provide higher efficiency, and they can provide grid support, frequency support, etc. In addition to that are the advancement that we need for power electronic converters to be able to convert different types of AC to DC voltage conversion or power conversion, and converting different types of electricity to another due to different types of renewable resources that we have. And these are now the real challenges and near real works and near future career works that we have in electrical engineering. And as everyone knows, the integration of renewables over years has been increased, and you can see in the graph over years, the integration of solar and wind and hydropower plant has been increased. But again, as I mentioned, they bring their own challenges. And in a near future, the electric systems or electrical engineering will need to um, be advanced in many aspects. One of them would be, of course, having faster and more efficient wireless charging stations for electric vehicles. The other one could be advancement that we have in solar technology. For example, as a simple another example, that the efficiency or the power conversion efficiency of the solar system that we have around us, even though we can see in almost every household in different countries, especially in Australia, the power conversion efficiency of the systems is still very low, and that's only around 30 to 40%. And you can see until only this specific area, we need a lot of work, a lot of advancement, so that we can extract higher amounts of energy from just sun. Integration of renewables, energy efficiency, robotics, and autonomous vehicles, that's another area of advancement that we can have. And artificial intelligence, again, nowadays, such as other uh, areas of engineering, they need to be adapted so that we can have more smart decisions and better optimization solutions for smart grids, for charging stations, for communications, for processing, etc. Another advanced technology we have is nanotechnologies, which results in more compact equipments, much smaller resistors, processors, and as a result, smaller and compact processing units. And as a result of that, we have new challenges now that we have higher, more compact devices. The interface or electromagnetic interface between different parts of these devices would be worse. And again, we need to have a lot of work and advancement in this area. Trending topics, as I mentioned, is renewable resources, their integration, and solving the challenges of renewable resources using the data and machine learning systems, and optimizing the operation and performance of smart grids, again using data and machine learning systems, and the advancement that we need in these areas. That's a quick brief about electrical engineering and different subfields of electrical engineering, and what are the aspects that are advancing or need advancement in electrical engineering. Now, if we just look at what we as EIT offer and what are different programs that we are offering in this area to provide you with the basic knowledge, with the pathway for your career in electrical engineering. So our program we have different set of programs, and you might be familiar. We have the first one I could mention is the Bachelor of Science in Electrical Engineering, which is a 3 years bachelor with a full accreditation from Engineers Australia for both online and on-campus versions, and it just provides a basic and conceptual units in electrical engineering. We have units such as renewable energy, electric machines, power converters. Of course, we also have mathematical units and programming units to get you familiar with that. And that provides you with the basic knowledge to work in public and private infrastructure units. After that, we have graduate certificates that are a pathway towards Master of Electrical Engineering. And graduate certificates that we have, they are covering the 1 year of Master of Electrical Engineering. And in the Master of Electrical Engineering itself, we are covering many units such as renewable resources, power system analysis, power quality, which are different, again, challenges that we have because of the integration of or high integration of renewable resources. Our master and both master and bachelor of electrical engineering are mainly focused on the power and integration of different types of energies with the power system. We have, of course, in our bachelor and as well as master, we have some basic units on electronics, on signal processing, etc. But the major core units are about power system and power system, as well as the integration of renewables. Then after that, if someone wants to continue with the research in the area of electrical engineering, they can join the Doctor of Engineering degree that we have, and that's a 3-year program that we have, and it consists of both coursework as well as project, and the project will be around a 2 years or 2 years and a half project on some specific area of interest for the student or for the company or the industry that they are working on. And in these projects, we really try to solve those specific research gaps or problems that require real research, and this would be what we are covering in the DEng or Doctor of Engineering that we have. On the other side, on the vocational training, we have different professional certificates, starting from arc flash. We have big data. We have circuit breakers, professional certificate in, let's say, power system protection, etc. We have, on general, EIT offers more than 100 different types of professional certificates. We recently launched a professional certificate on lightning and earthing design as well. So you could just look at these different types of professional certificates, and based on your career and based on your interest, choose the ones that you are interested. Also, we are offering advanced diplomas, different types of advanced diplomas that again are accredited. In electrical infrastructure, we have advanced diploma of applied electrical engineering and instrumentation, illumination, etc. In these advanced diplomas, we cover some of the basic mathematical units, some of the basic electrical engineering unit, and then we also have a big focus on the application and industry side of those concepts. And these are different types of advanced diplomas that we have. Again, from professional certificates, you can go towards advanced diplomas, and from advanced diplomas, you can have some credits towards the undergraduate certificates or Bachelor of Science, and this could be a full pathway from what we call as professional certificate towards a Doctor of Engineering, and these are different units and different courses that we are offering to suit everyone's need. Our main focus in EIT, and this is something that I really say from the bottom of my heart, is our real focus is industry. There are two reasons that I really want to mention here. Is firstly, our lecturers are mainly casual lecturers that are coming from industry. So we don't normally use academics that are only working in academia. We are using lecturers who are really working in industry, and once they come to the class, and they are gonna provide and bring their industry experience to the students. That's one of the reasons that I really say we are industry focused. The other thing, the other side of that is our students or our potential students. You guys are some of them. Our students are normally working in industry as engineers or as technologies, etc. And they want to advance their knowledge or promote their career, etc. So both the students are working in the industry as well as lecturers working in industry brings an environment that is very much industry focused and industry based. And as a result of that, we use many practical assessments and we use many software tools that are being in use industry as well. So here I'm providing a list of some of the software tools that we have access to and we are providing assessment. One of the important ones that I really would like to focus is the DigiSilent Power Factory, which is one of the most expensive software tools we have around in industry. And for example, here in Australia, a lot of consultation companies or power system operators are using this software for analyzing the power system, integrating generators, etc. And now we are encouraging our students, or in other words, even we are forcing them through our assessments of different units for both bachelor and master to use this software tool to get familiar with that and to solve some of the real industry problems case study with that. Of course, we are using some other software tools like MATLAB Simulink for analysis. We have ETA, PSCAD again. PSCAD again is another industry-based software tool, or we use SPICE also in some of the units that are mainly for electronics, etc. In addition to that, we have 3 or few weeks of intensive workshop, hands-on workshops for those students who cannot get the RPL or they don't have industry experience. They need to come to our workshop, and in these 3 weeks of workshop, they need to do many different experiments, from very simple experiments like checking resistance, voltage, etc. across different devices, up to programming of inverters similar to uh, the inverters that we have in industry for energy storage systems or for PV inverters. So this is another advantage that we have, and it really makes you ready as a student for your future career with an hands-on experience and understanding these things, these basics from your experience. In addition to this hands-on workshop that are normally face-to-face, we have remotely controlled experimental setups like programmable inverter, or we have another emulator of the transmission line. And as part of our units and assessments that we have for different units, the we are providing students access to these experimental setups for those especially online to be able to get some hands-on experience with different devices that has been used in the industry. On potential job outcomes, of course, you can go work in the design of electronics and electrical systems, in oil and gas, system engineering, mining, manufacturing, electric vehicles, and different types of industry. And nowadays, with the advancement, there are two trends that is happening nowadays, and it brings higher opportunities or more opportunities for electrical engineer. One is integration and going towards more renewables. That's something that all different companies like mining companies, manufacturing companies, etc., are trying to integrate more and more renewables with their power system. Another thing is the going towards more electric components and equipments, and like those devices that previously were just mechanical, like big trucks, now they are becoming electric trucks, and this all brings more opportunities for electrical engineers to work in these areas. And again, that makes the electrical engineering one of the most applied engineering that we have in between different types of engineering. And yeah, of course, we have many also graduates from different that who are working in different industries, and you can see their feedback from our website as well. And that's all from my side, unless there is a question, or I will answer the question a bit later on. Thank you very much. Hanana, you want to take over, please?
Yes. Hi, Dr. Hussein. Hi, everyone. First of all, thank you for having me. It's a great pleasure to be here, and thank you for the attendees for joining us. So let me give a brief overview of my background. My name is Hanane. I am a Moroccan Canadian, an electrical engineer. I have worked across Morocco, Canada, and United States of America, where I have blended hands-on experience in electrical engineering. At EIT, I proudly wear two hats as a lecturer in electrical engineering and also a student ambassador. I have been awarded for multiple prestigious awards, including EIT Women in Engineering Scholarship, Dean's EIT Dean Scholarship for academic excellence and high achievement. I'm also recognized as a LinkedIn top voice in electrical engineering, electrical design, and system design. I hold a technical university degree in electrical engineering from a higher school of technology from Morocco. And also I hold a Bachelor of Science in electrical engineering from EIT. Currently, I'm pursuing a Master of Engineering in electrical systems. So today I'm happy to share my experience at EIT. So let's start with the first question. How did I find EIT, and what led me to enroll with EIT instead of other universities? Well, one of my ultimate goals is to become a licensed professional engineer. So accreditation for me is very important. So one aspect I start looking for is accreditation. When it comes to online engineering education, it's very challenging to find a reputable and accredited university. So I start looking till I came across EIT. So that's one thing. The second thing, EIT is industry focused. So when I look at program structure and unit content, I see that they are very relevant to industry trends. And also the programs are accredited because, you know, in engineering, we work on projects that require compliance with standards, international standards and national standards like IEEE, NEC National Electrical Code, and IEC, International Electrical Code. The other aspects, they are flexible. So for me as a professional, and also I have other, like I am married and I have two young kids. So I have other commitments. I have professional and also personal commitments. So I need flexible online learning. So I can study anywhere from anywhere and also anytime. The lectures are experts. So they are expert in industry. So their teaching is based on real world case scenarios. So you see that there is alignment between the theory and the practical, which is very important, especially in nowadays. Last but not least, EIT is one of the only universities specializing in engineering. So the second question about inspiration. My dad is a mechanical engineer. So I grew up around blueprints, tools, and technical talk. The reason why I choose electrical engineering because of versatility, and Dr. Hussein, he covered that the aspects of electrical engineering very well. So it's versatile field. It's not just one thing. It encompasses numerous sub-disciplines like power system, renewable energy, telecommunication control system, signal processing, AI and machine learning, instrumentation, robotics, automation, and many more. And also, you can work anywhere. You can work like in education, engineering, engineering consulting companies. You can work in oil and gas. You can work in healthcare, government, transportation, renewable energy, and yeah, so it's a very versatile field. So when it comes to my experience, to be honest, EIT really exceeded my expectations. As I said, you don't get only the theory, you get also the hands-on learning, because you have access to remote labs 24 hours 7. So you get to design models. You can simulate you can test your calculation, you can simulate your model. So you get that hands-on learning with advanced software like ETAP, MATLAB, Simulink, like BaseCAD, AltiSpice, and Dig Silent Power Factory. So, and also without forgetting the LSO, Learning Support Officer, which I call them the backbone of EIT, because, you know, as an online student, you will face like technical issues. So you need a good support for that. For the other question, yeah, I want to share one of the most challenging and memorable moments I had in EIT. That was just last year, when I was doing my Bachelor's of Science in Electrical Engineering. So when I started EIT in 2022, I had a plan. So I said in 5 years, I need to complete my Bachelor's of Science in Electrical Engineering, and also I have to complete my Master's. So in order to do that, I have to complete my Bachelor's in 3 years and my Master's in 2 years. So last year, like the first semester, I was left with 6 units, and 6 units plus the project, the final year project. So I wanted to leave I want to focus only on the last semester with the project. So that's why I had to take all the remaining units, which were like 6 units. And that exceeded the typical course load. And I faced many challenges. It was like a huge challenge to have like professional commitments, personal commitments, and also you take like over like 6 units. So it was too much. That required exceptional time management, discipline, strategic learning to balance family, work, and school. So how did I overcome this challenge? I created a detailed study plan and prioritized tasks. And also I utilized active recall and problem solving practice. And of course, you need to maintain dedication, determination, and perseverance throughout the process. For the outcome, that's why I said it was challenging, but also rewarding and memorable, because I was able to achieve high distinction in all the 6 units. And after this semester, I was awarded for the 4th time in a row the EIT Women in Engineering Scholarship for the highest academic performance, high distinction in each course. And that's why I feel so grateful for EIT for their support and encouragement throughout the process. That's on one hand. The other hand, that reinforced my ability to handle academic pressure and also professional pressure. So now I feel like I am more resilient, more commitment. I know how to manage manage like this, stress and also the pressure when things get like very tight. Yeah. So the next question, what advice I would give to prospective students if they are considering EIT? Well, first of all, you need to define your goals. What you want to be. You want to be, for example, in electrical engineering field, you want to be electrical engineer technologist, or you want to be professional engineer. So it depends, but EIT offer all these possibilities. And I would say if you're looking for example, like you want to get your degree or your diploma and then you can get a job, EIT is for you. Why? Because it's industry focus. You get the theory, which is the foundation for electrical engineering, and also you get the real world application. With, as I said, with the lecturer that they are expert, and also they always provide real life, real world case scenarios. I would also advise them to embrace online learning. So online learning, it's something that you need to be committed, disciplined. And one advice I will give to prospective students and also to current students, which I find it the key to success in online, especially at EIT. I'm talking now about EIT. You have to be very serious about your pre-recorded lectures. For me, pre-recorded lectures is the key to success. Why? Because they provide the foundation for your units, for your topic. They provide the foundation to be serious about your learning. They provide the foundation to build that relationship between you and your lecturer, because when you watch your pre-recorded lectures, you will get motivated to attend the live tutorial. And for example, let's say you can't attend live tutorial, you can go back to the recording, so you will make your life easier. That's one thing. Just I came to my mind now, and I wanted to mention it. And also, you have to manage your time effectively. Like I said, it's it's on online. So, and the good thing about EIT, once you start your term or your semester, they give you all the assessment like schedule and all the material that you can plan your time accordingly. And also, I would say don't be afraid to ask for help. The lectures are very responsive, 24/7. So you send an email with a 24-hour maximum the reply, and also the LSO, they are very responsive and supportive. Next slide. For me, I would say here that this experience at EIT broadened my perspectives academically, professionally, and personally. Academically, because it's industry-focused learning, it's provide real-world application of principles, especially for me, as I was already a professional. I already had like over 10 years experience in electrical engineering. So I can tell that EIT is industry-focused. And also to provide a global perspective, because you meet students from like around the world, and also the lecturer from the world. So you expand your knowledge, and you also expand your networking, and you learn about others countries' standards, and also electrical engineering exposure. Professionally, I would say it's increased employability through accredited industry-relevant skills. So you become like accredited, because all the programs are accredited at EIT. So you become more accountable and accredited. It has networking opportunities with global professionals, and also improves ability to adapt to diverse work environments. Personally, I would say it enhanced discipline and time management. Also the resilient and problem-solving confidence, and also expand the cultural awareness and network. So this slide, it says, what was my favorite aspects of studying these courses with EIT? First of all, hands-on hands-on application through simulation and lab-based projects. As I said, this is a huge plus that you have access to remote labs 24 hours 7 with advanced software in electrical engineering. So you can, for example, like, and also I said in the chat box, like somebody asked how you can, if IIT provide training for the software. Yes, yeah, IT provides training for software. And also there is YouTube. You know, you can go to YouTube and you can look, for example, software. You have the software through EIT Remote Lab, and you have YouTube. So you can learn and practice. So this is very, this is for me, it's very important to get that hands-on experience. Lectures, they are very knowledgeable, as I said, industry focused. Yeah, and also as online students, sometimes you feel like you are isolated because you are, you know, you study alone, but that's not the case, especially for me. I have been with IT since 2022. So you get to expand your networking, and you get to you know, to make friendship and good relationship with you know, with lecturers and also with peers. And also with the EIT support, because you feel like you are in family rather than you are like a number. And also I would say access to cutting edge software and resources. Yeah, thank you.
Thank you, Hanan. That was very insightful. Thank you for letting us know about your experiences and how that has been for you. So,
Yeah, thank you.
yeah, it was very insightful. Thanks. And Dr. Hossein Tafti, thank you as well for giving us your knowledge and your industry experience and just passing on some information to our students and our future students. That was very great. So to all the attendees, you may ask questions in the chat box or in the chat itself, and Dr. Hossein Tafti and Hanane Oudli will be able to answer your questions. So we'll give you time to do that right now. And while you guys are still thinking of your questions and asking your questions, just please take note of the screen that's currently in front of you with regards to the certificate of attendance. Just take the QR code, you can scan that, or alternatively use the link, and it will direct you to a survey that you'll complete, and then that will also be part of what we use to get the certificate to you. Like I had already advised earlier on, this will be sent to you either on the 14th or the 15th. So between those 2 days, that's when you will get your certificates of attendance, as well as the PDF for this presentation. The copy will be sent to you on your email. So if it's not in your inbox, can you please kindly check your junk or spam mail? Let's just check if we've got any questions here in the meantime. So Abu Bakar is asking, and I think this might be for you, Dr. Hossein Tafti, how is the pathway to a Master's of Graduate Diploma in Electrical Engineering through the graduate certificate?
Okay, what I understand is the pathway from the advanced diploma, they can go to the Bachelor of Science, and then from the Bachelor of Science, they can go graduate diploma, which again has some of the units from the master. And that graduate certificate will have 1 year of master units. And after once they enroll in the master, they will get the credits for that first year of ME units or master units. That's what my understanding is.
Thank you for that. And then we have our next question, and the next question is from Maxwell, and they're asking, hi, what course can I take to enable me to successfully design and implement power inverters, DC chargers, and solar controllers?
Okay, so I can take this question. Both bachelor and master units that we have, they have 2 units for power conversion, and power and design of power converters. So if someone takes either one of the based on their situation, they get either the bachelor or master, they would have at least these 2 units. At the moment, we are also introducing a new professional certificate or grid integration of renewables. I think that's gonna come somewhere end of this year, and that would also have the basic principles of the design of power converters for renewables, and that, I guess, that would answer this question of what unit that we have or what course we have about the design of these converters.
Thank you for that, sir. And then we've got another question from Augustine. And Augustine would like to know, why is it that EIT do not offer training on ETAP and MATLAB?
I guess that's something Hanane also answered just partly. Most of the software tools, I mean, if we have them in assessment and if we have part of the units, normally we add some uh, training or videos that we create ourselves specific to that assessment, to that software. But a lot of time, YouTube and all these AI tools have a lot of examples and demonstrations, and we don't want to really replicate what exists. Again, for the specific tasks we have, but as a general, we refer them to the online resources. Sorry, Hanan.
Yeah, so I want to add something. So the most important thing and the most critical thing is to have a licensed software, right? So EIT, with EIT, you have access to the software 24 hours 7. So you have access to all the advanced software like ETAP, MATLAB Simulink, Power Factory 6 Silent, LT-Spice, AutoCAD, SolidWorks, all the advanced. So what you really need to go to YouTube. And I'm sure everyone has YouTube now. So it's easy for you to learn and to practice, you know. So that's what I would advise. So the most critical part is done. You have the software, so you are set. You only have to have time and motivation to practice.
Thank you for that. So let's just see what is our next question here. Okay, we've answered that one. Are there online master's courses in engineering? I've answered this one, but I'll just go ahead and answer it for the rest of the people that may not have seen my response to that. So we do offer, so all our HE courses can be taken online or offline, or rather on campus, and that would require you to relocate to Australia. So the short answer to your question is yes, we do offer our courses online and on campus, except for our VET courses. Those are offered only online. And then we've got a question from Douglas. When are you going to introduce elective courses in second year of MEng in electrical systems, as it is now in MEng industrial automation, in order to accommodate modules like MI605A, machine learning for industrial automation, and MME606A, data analytics for industrial applications?
The simple answer is from the coming semester. We have already have gone through the process to add electives for the second year master units, and we have already received the approval from the course advisory committee, industry partners, as well as academic board. So it will be most probably implemented from the coming semester in August or in September, and students will have elective options, especially the 2 units that you mentioned, MIA 605F. That's one of the elective units that we have already introduced and has been approved. For the MEE 606, I don't think we have included in the elective units list of elective units, but that's something that we can look into, and I will follow up on this. Thank you.
Thank you, Dr. Hussein. And then let's just check which other questions we have. I think we might have answered all of them for now. Let's just quickly go through the list. Okay, so we've got a question from Shruti. I already did my BEng degree in electrical and electronic engineering for 4 years. Do you advise to take on Masters of Engineering course at EIT? Will it still be a 2-year course? So,
Yeah, you already answered, please.
yeah, okay. So basically, you can contact one of our course advisors, and then we'll just go through the entry requirements with you and just see if you are eligible to apply for the masters. And then, will it still be 2 years? Like I had mentioned in the answer to you, the duration relatively remains the same. And if you are a full-time student and you're not doing it part-time, then it will still be 2 years, although you can get credited for certain modules. That will just basically just mean that you won't be attending those modules. You'll you'll be sitting them out because you are competent in that, and then it will largely remain the same in terms of its duration. So I hope I answered that question. And then we've got a question from Dalcia. I have been working in industry for 5 years as an automation engineer, never used MATLAB. I know mostly used in R&D. The sorry, other labs in MATLAB examples on how you apply MATLAB in industry. Who would like to take that question?
Yeah, I can give my insight. Yeah, of course,
Okay.
MATLAB is an expensive software that not all the industries are affording to really use it and purchase it. One of the advantage we have here, we have the full campus license, and every student can use it. As you also, as Delicio also mentioned clearly, that's a software that has a lot of advancements and has been used really in R&D works. Uh, it and one of the main features of MATLAB is the extensive examples and extensive documentation that it has, either online or in many videos that they have created, and even just searching a quick search in their website, in Vatworks website, you would see a lot of case studies of simulations of real world industry problems or case studies. So um, we are not, again, we are not only using MATLAB software tool in all our units. It's a kind of mixture of more industry-based like Power Factory, ETAP, PSCAD, etc., as well as MATLAB in some of the units, so that students have kind of a taste of both or different types of software tools. And our aim is really, for example, if students are having 8 or 9 units in their whole, let's say, master, we really want them to experience at least 8 or 9 different software tools, and that's where assessments are being designed to have this variety of software tools. Hopefully that answers your question.
Thank you, Dr. Hussein. Dulcie is saying thank you for answering. And do we have any more questions? Because Tupisa's just answering the ones in the chat right now. Um, Shafiq, you can book a call by going to our website and just filling in your details and just specifying what your inquiry is about and selecting the time and date that meets your schedule. And then one of our course advisors will give you a call. And then, okay, that's been answered. Okay, I believe that brings us to the end of our session. Yeah, most of these questions have been answered as okay. Aladdin, you may ask your question. Kindly type your question, please, into the chat box so we can answer it for you.
Yes, there are two more questions I can see in the Q&A. One is the master's on a full-time schedule, or will it be possible to do it part-time? I guess the simple answer is both are possible. Then the other question from Maxwell, what scholarships are available for students from developing countries? I guess this is something you can answer. I don't know the exact information.
Yes, so with our scholarships, they are open to international students. However, they are partially funded. So you'll be given a certain percentage off. It won't be 100% fully funded scholarship or bursary. And this will obviously be based on the merit of your academics. Thank you. Okay, I see there's another question. When do the lessons start for electrical engineering? Okay, so that's not a straightforward answer to give. That's because our courses have different schedules. So you can just go onto our website under the course schedule for our courses that we offer. You can just go there and see when they're scheduled for. And I'm sure that will be able to answer your question. Okay, so I think we can just answer one more question. I'll hold a DIT certificate. How is it valid at EIT? I'm not quite sure of the question.
Yeah, so it depends what he's interested. Is interested like in a diploma or a bachelor's degree or a master's degree. So what type of degree or diploma you are looking for? So it depends on the, what you're looking for, because each course has its own requirements.
Thank you, Hanan. So guys, we're gonna wrap up the session for today. Thank you all for attending, and like I've mentioned, you will be receiving your certificates of attendance. You can take the screenshot, you can take the scan of the QR code or the link and just fill out the survey, and that will be sent to you on the 14th, between the 14th and the 15th of April. Thank you all for attending, and Hanan and Dr. Hussein, thank you for your time once again. Have a lovely
Yeah.
day.
Yeah, thank you. Thank you, Dr. Hossein, and thank you, Jaime.
Thank you very much, everyone. Thanks. Thanks,
Thank you,
Hanane.
meeting
Thanks,
you here.
everyone. Have a good
Thank
day.
you. Thank you,
Enjoy the rest
everybody.
of your day.
Yeah, have a good one. Bye.